Okay, so I'm going to be modeling this multiplication problem, 237 times 43, in these three different methods: common method, lattice method, and the partial products. So I'll start with the common method or standard. So I'm just going to set up 237 times 43. I'm going to put the number with more numbers, the bigger number, on top. And then I'm going to do 7 times 3, which is 21. So I'm going to put a 1 there, carry the 2. 3 times 3 is 9, plus the 2 is 11. So put the 1, carry a 1. 2 times 3 is 6, plus 1 is 7. I'm going to put a 0 down here, and then do 4 times 7 is 28. Put an 8 down here, carry a 2. 4 times 3 is 12, plus 2 is 14. Put a 4 down here, carry a 1. 2 times 4 is 8, plus 1 is 9. And then essentially I'm just going to add these two numbers. So 1 plus 0 is 1. 8 plus 1 is 9. 7 plus 4 is 11. And then 9 plus 1 is 10. So that's going to give me 10,191. So I'm going to go ahead and box that in. And then I'm going to go ahead and move to the lattice method. So the lattice method, essentially we're going to start with a box. And now that we have the box, we are going to divide it by the numbers, essentially. So since 237 is going to go on top, we need to have 3 boxes. And then since we have 43, we're going to need to have 2 boxes horizontally. So that's how you're going to set it up. And then we are going to draw diagonal lines through these boxes. So I'm going to kind of turn my sheet. I'm going to extend them a little bit past, just so we have room to draw our numbers and things don't get kind of mixed up. So that's kind of the setup we have. So we're going to start by doing each one individually in the boxes, if that makes sense, which I'll show you. So 7 times 4 is going to be 28. So in this first box right here, how it's split, we're going to put a 2 in the first box and then an 8 in the second box, since 7 times 4 is 28. Now 7 times 3 is 21, so we're going to do the same thing, but with 21. So we're looking like that so far. 3 times 4 is 12. 3 times 3 is 9. So since that's a single digit, we're going to put a 0 in the first box and a 9 in the second box, since we don't have any 10s for that. And then 2 times 4 is 8. Similar thing, 0 and an 8. And then 2 times 3 is 6. Same thing, 0 and a 6. So now that we have this, we're going to go ahead and add across the diagonal lines. So this one, in this diagonal line, there's only a 1. So it's going to be a 1. We're going to carry that down. This one is going to be 8 plus 9 plus 2. So 8 plus 9 is 17 plus 2 is 19. So we're going to put a 9 there, and we're going to carry the 1 to the next diagonal of boxes. So we have 2 plus 2 is 4, plus 1 is 5, plus 6 is 11, plus 0 is still 11. So we're going to put a 1 down here and carry the 1. We have 1 plus 1 is 2, plus 8 is 10. So we're going to, plus 0 is 10. So we're going to put a 0, carry the 1, and then just 1 plus 0 is 1. So we end up with 10,191, which is the same answer we got from the first one. So I think it's safe to say that that's the right answer. But we're also going to do the partial products method. So moving on to partial products, we're going to kind of set it up like common method, but it's not going to be the same. So just again putting the bigger number or the one with more numbers on top. So we have 237 and then 43. Now instead of the common method where we kind of worked individually through them and then we added all of them, this is going to be different. So we're going to do 3 times 7, and that's going to be 21. So instead of like writing down the 1, carrying the 2, we're just going to write 21. Now we're going to move to 3 times, it was 3 with common method, but now we're going to do 3 times 30. So 3 times 3 is 9, so 3 times 30 would be 90. So we're just going to write 90. And then 3 times 2, which would really in this method be 3 times 200. So 3 times 200 would be 600. So we're just going to write 600. And notice how I'm still kind of keeping these lined up so I can keep track of my place values. So now we're going to move to 4 because we multiplied 3 by all of the digits above. So now 40, because it's in the tens place, times 7 would be 280. So we're going to write that. 40 times 30 is going to be 1200. And then 40 times 200, which really I'm doing 4 times 2, which is 8, and then adding 3 zeros. So that would be 800. No. Sorry. It's going to be 8,000. And then we're just going to add these all up. So 1 and 0, 0, 0, 0, 0, so that's just going to be 1. We have 2 plus 9 plus 0 plus 8 plus 0 plus 0. So 8 plus 9 is 17 plus 2 is 19. Put the 9, carry the 1. 7, 6 plus 1 is 7, plus 2 is 9, plus 2 is 11. So put the 1, carry the 1. And then we have 8 plus 1 plus 1, which would be 8, 9, 10. So we're just going to write 10 because that's the last place. So we get 10,191. So that's how you do 237 times 43 in the common method, lattice method, and in partial products.